Welcome to my presentation, looking beyond the scope, Scala application from an external lens, I'm Paweł. I do Scala and some DevOps at LeadIQ, and I'm also a technical trainer at Comarch. I do also courses related to DevOps areas. So let's start. So this talk will be a little bit different than most of what you saw here. I will move our focus out of internals and look at our app from a distance. So what triggered this talk? If I would need to choose a single word, that would be imperfection. You go through design, implementation, tests, you then run your app, you iterate, of course, and still you end up with a solution which is not ideal, right? Even though we're very lucky because we use Scala, and we use language which is great and which enables us to write great software. We have lots of tools and idioms. A lot of them were mentioned during presentation. I will not list them all. You can have a look at the slide. And still, we are imperfect. We write imperfect software. Sometimes we are even lazy, and we have some shortcuts. We have a limited amount of time. By the way, maybe because Scala enables us to write FP code, it attracts, lazy people to use it, or maybe we are just lazy by default, by definition. Okay, so my point is that there is never a final solution. There is constant improvement. It's constantly evolving. There are some bug fixes, and as I mentioned, we have a limited amount of time. We have to deliver something in a limited amount of time, almost always. The world is not infinite. I mean, maybe it is, but the time for us is not infinite, definitely. So we always, at any point in time, we have only current solution, not the final, but just the current one, which will probably never be final. Or if it's final, it means that our project did not gain traction, maybe no one is using it. And it's always imperfect. And even if you assume that, okay, my app is almost great, it's perfect, you have to run it somewhere. You have to run it in a real world, and the real world is imperfect, and then brings in the imperfection to our apps. We also need to remember that what we create, the software we create, is just an element of something larger. Usually nowadays we have distributed systems, so we have a bunch of apps, multiple different apps, different services, running in multiple number of instances across geographical zones and so on and so on. Each app has its own backing services. By backing services, I mean all that Mongo or queues, Postgres or databases and so on that your app needs to talk. Also apps, they exchange information between them via some protocol like HTTP, gRPC, or whatever. They share, they send messages to each other. And as mentioned before, we need to run it somewhere. In this talk, I call it target platform. By target platform, I don't mean JVM. In this talk, I mean rather a virtual machine or on which you run a container, because nowadays, I mean, containers is a standard, right? You can see containers, Docker, or Podman, or OCI, Open Container. You can see them everywhere. So you can either run it on VM, or Kubernetes, or somewhere else. But you need to run it somewhere. Eventually you write your app, because you want to deploy it somewhere so it works. So today, I'd like us to step into the role of Kubernetes, right? So, or the other platform that you run your app on. So we are Kubernetes today, okay? All of us, we are Kubernetes. We will be looking at our app from a distance. From that perspective, okay, let me switch the slide. Okay, works. Some of the topics mentioned here in this presentation are connected with cloud. Oh, sorry. not this slide. Okay. So nowadays we tend to say that we run something in cloud. It's a buzzword, by the way, but who cares? But there are different rules in cloud. So before, I mean, 10 years ago, 15 years ago, when you were running your app, you started it, and it was there running for a year, maybe for 2 years. I don't know what is the longest uptime of an application without any interruption. But then the cloud came in, and here we have much different rules. So applications are ephemeral. So we have frequent restarts, and not only due to the failures inside the application, but maybe some orchestrator like Kubernetes it can decide at any point in time that, okay, I don't have resources here, so we'll kill the app here and put it there on a different node, or for any reason. But we have much more restarts. And as a natural consequence of that we have such many restarts, we need to care more about fast startup and graceful shutdown. In the past, we didn't have to. If your app starting time is, 10 minutes, and you do it once a year, who cares? But if you start an instance of your application, approximately 5 times a day, you have some restart, yes, it matters. Of course, it's good if your app is stateless, and then it's easier to scale horizontally. We'll not go deeper in this. And as I mentioned, we have containers everywhere nowadays. OK, let's focus on fast startup. Let's answer a question. What does it mean? When is your application started? So when you click the red button, deploy or release, or your CI/CD pipeline puts it somewhere, is it started or not? Or is it fully initialized or not? Is it ready to handle incoming requests? Usually, it looks like, always it looks like this. So you can see the timeline. And after your app is started, before it is fully initialized, usually it's not ready to handle incoming traffic. If any request is forwarded to an instance during that period of time, it will fail, right? Because there is nothing to handle it. After it is initialized, OK, great. Then it works. Of course, it's not always like this. I mean, after it is initialized, it's maybe also not ready in the middle of the work, but let's assume it is. So what can we do? We should strive for making this period of time as small as possible, right? So we want our apps to initialize very quickly. So we can try to parallelize initialization. It has one drawback. You will need more CPU at the startup. It usually is not a problem, but when you start many instances at the same time, and they use much more CPU just at the startup, and then later on less CPU, you may end up having some problems, having some issues, because they may be starting even slower, and then some health check that can kill them, and the process restarts, and so on and so on. I had such situation. So as recently I was working mainly in Zio, in Scala. The examples, high-level examples here in the presentation will be with Zio. So in Zio, when you want to construct dependencies, requirements, there is a concept of Z-layer, and Z-layer by default it tries to construct everything in parallel. OK, let me switch to the next slide, and we've discussed startup. So now let's go to the end of lifecycle of our app, and we'll discuss shutdown. Most of your apps, probably most of your apps, are by definition running for forever, right? If you start HTTP server, it's there. It should be running all the time, right? But it can receive a signal. Usually it's SIG term, but it's configurable, of course. That should trigger a shutdown. What should your app do? It should refuse any new incoming requests. It should finish current ones, close all the resources, and so on, and so on, and so on. It's an easy concept. Speaking about resources in Scala, of course, we have cat resource, we have ZL scope. Previously in ZL 1.0, it was Z-managed. We have all flavors of those methods like acquire, release, blah, 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 blah. We have a lot of them. And FX systems work quite well here in terms of signal handling and interruptions. The resources are properly closed and so on. So usually you don't have to worry too much about it. But sometimes there are edge cases where you need some manual work will need to be done here. Okay, this is the timeline. So once your app receives a signal, please shut down. So that's what Kubernetes does, or any other, like Docker, for example, the same. It sends a signal and says to the app, please shut down. If the app really initiates a shutdown, it should successfully be finished by a few seconds, maybe. If it does not, by default, in Kubernetes, of course, everything is configurable, but by default, after 30 seconds, it's forced. It's killed. It just killed, right? In cloud, when your app doesn't work, you don't. You just kill it, and you spin up a new instance. So what can happen if it's not implemented or if it's not working properly? Of course, you might have some data losses. Resources may be not properly released, but that's not all. Also, it may take more, if it takes more time to close your app, so for example, instead of 2 seconds, 3 seconds, 5 seconds, it will take half a minute. Imagine what happens when you try to do a rollout. A rollout is a process. Imagine in production you have 10 instances of your app, and you introduce some new killer feature, and you want to release that to production. So what you do? Usually, because there are multiple strategies there, but usually you spin up a new instance with the new version, you kill the old version. The next instance with the new version, you wait for it to be ready and kill the old one. And if the graceful shutdown is not implemented, you may not only have data losses, but also it will take much more time. The full process of rollout will take more time. Oops. Please work. Okay. Okay. Let's now think, how do we know if our app works fine? Of course, it's deployed somewhere, it's working, it's running. Or let's revert a question. How do you know if something is wrong, actually? If our app crashed, you know what it means, right? You're running it, and then there is some fatal error or exception, and the main thread is down, and it's crashed. Then at least the problem is visible. It's not ideal, but at least we know. And if something crashed, it can be automatically restarted by some restart policy. It's usually called like this. Okay, but let's have a look at this code, right? You have a program, then you have catch all, you have some error, you just log it. And imagine the program fails. What happens then? You log the error, and to the operating system, what is returned? Exit code 0, which means success. So if the restart policy only restarts in case of failure, this will not work. I know it's trivial, but sometimes happen. Yeah, I saw something like this, that the app crashed. It was not restarted, only logged, oh, sorry, I crashed. And OK, from the point of Kubernetes or Docker or something, it was success. Instead, you can explicitly return some exit code, or just not catch, but print the error and do nothing, and just continue with the failed program. It's usually in it's called tap, I think. Yeah, it's the common name for those things. Yeah, so when you return success, if you failed, it may mislead the operating system. And it may prevent automatic restart. OK, so if it crashed, that's easy. We have so-called restart policy. If it's not crashed, then it still works, right? If it didn't crash, it works. But does it work fine? Let's find out. What if there is some hidden failure? So it pretends to work, but internally it doesn't. So we need to detect it somehow or either give time to recover, or what do we do in IT if something doesn't work? We turn it off and on again, of course. Yeah. So we restart. That's the solution to every problem. Sorry, the solution to every problem is hash map. So yeah, hidden failures, they happen sometimes. They don't cause your whole app to crash, but internally, something is wrong. As an example, let's think of an app which has HTTP server inside. It works, server is up and running, but when you send a request, 500, 500, 500, internal server error, and all the time, yeah? So it's clearly not in a state we wish it should be. Okay, so in that sense, if something crashed, we're lucky because we know. If there is a hidden failure and we don't know, that's not ideal. Even worse if client knows and we don't know. That's the worst case. Okay, and that's how our app looks like. So when Kubernetes or Docker, when they look at the app and there is some hidden failure, they don't see the fire inside. They only see, okay, this is fine. Okay, if it's fine, I do nothing. Just keep running. Okay, how can we deal with that? We have health checks. You may have heard this concept under the term of probes. Someone can tell you probes or health checks. It's basically the same concept. So basically, something, some target platform asks application, are you healthy? Are you busy? And health checks are executed periodically. In Kubernetes, for example, we have two main kinds of health checks. We have more, but those two, I think, cover all I want to say about. Liveness probe. In case failure is detected, then your instance is being restarted. Of course, not after the first failure. By default, you need to have 3 consecutive failures. In case of readiness probe, it's not restarted, but it's marked as not ready, and as a consequence, no request will be forwarded to this instance. So we have 10 instances, and 3 for some reason are not ready. Only the remaining 7 will be handling incoming traffic. Of course, it's responsibility of developers, of us, to implement those health checks. Possibilities are endless. You just need to detect situations where your app is not ready or where your app needs to be restarted. This is just an example. I'm not saying that it's your use case, but this just checks if it just does very simple query on Postgres and detects if the connection to Postgres is lost. That's the real example. I mean, not this code, but the real example with Postgres. I had an app which was losing connection to Postgres after some time. Postgres was fine. You needed to restart the app, and it worked again. Of course, you need to fix that internally, but as a workaround for some time, you can just detect it and automatically restart, and everyone is happy. Okay, what can go wrong with health checks? Of course, we may restart too eagerly. There may be too frequent restarts. Like if we will fail health checks for no reason, our app will be restarted, even if it doesn't have to be. Also, if you restart your app, you restart everything inside, right? So we look at the app as something atomic, right? So it's either working or not working, started or not started. But inside our app, we have many threads. We have many different pieces of code with different responsibilities. So if something is wrong inside, maybe we can try local retry. That I will talk about it in a second. So let's imagine that we have an app with HTTP server that does something. For example, internally connects to Postgres to read some data, and in the same instance, we have a Kafka consumer or a bunch of Kafka consumers, and one of them failed, the rest is okay, or there is something wrong with the connection to Postgres. And if we restart everything, we'll kill the consumers. There will be Kafka rebalance. Maybe we'd want to avoid that. So maybe you want to have more fine-grained control. I mean, health checks are okay. They can help us. They're very quick to implement. If something is wrong and you don't want to wake up in the middle of the night to just press the button to restart, they're great. But if you want to have more fine-grained control, you have to do maybe local retries. Maybe just restart part of your program, not the whole app. So here as an example, I think something similar was part of yesterday's presentation. So we have here is an example of schedule where we can describe, in this case, when rate limit is detected, we'll try to overcome the rate limit per minute first, and then if that fails, we'll make requests less frequently, approximately once per 10 minutes. It's jitter, so it's a little bit randomized, and try to overcome hourly rate limit. If nothing works, then of course we fail, but we don't fail at the beginning. This is how you use it. You just pass in the schedule. Okay. Okay, taking care of fast startup, graceful shutdown, probes may still not be enough. Probes, of course, health checks, health checks. We go further, and this slide is entitled Observability. I think it corresponds well with the title of presentation, right? We have to observe the application. Okay. By observability, we mean monitoring, logs, also tracing. So when we have monitoring logs, we need to decide if the metrics we want to use pull-based or push-based solutions. Of course, logs are always push-based because you print the log, so you push to the stream some string. Of course, nothing is for free. If you have too many logs, that can significantly slow down your application. That really happens, yeah? I remember that I once changed log level to debug or to just, and the application started working 2 times faster or something. Okay, here's the example of monitoring. I think, yeah, Prometheus metrics. So we have a metric which is incremented once we start some background job. Of course, also example of logs. In case of logs, we can also encode some additional annotations, additional information that can help us later trace what happened. Another example with Zio, we can annotate logs. What's great about this? You don't have to put Zio log info just inside those curly braces. You can have another effect that internally calls some Zio log something, and the annotations are forwarded. So they will be everywhere underneath. Okay, so we have metrics, we have logs, but why? Maybe we would like to have nice dashboards, maybe automatic alerting, so if something goes wrong, you get an email or something. Yeah, this example of dashboard in Grafana, but maybe also for something else. It's not limited to just alerting and dashboards. We also, nowadays, want to scale. If we want even more, we want to auto-scale, so scale automatically. Of course, assuming our app is stateless, then it's very easy. If it's not, it's doable, but it's much more complicated. And exposes some metrics or logs. From logs, of course, we can also derive some metrics. So you don't necessarily need some monitoring server. And you can auto-scale. Most of the time, you auto-scale based on CPU and memory usage. For that, you don't need to do anything. It works out of the box. And most of the time, that's enough. But sometimes, custom metric can help. Imagine an app with Kafka consumer inside, and the consumer consumes a batch of messages at a constant rate. So it uses the same amount of CPU all the time, no matter if we have 100 messages on Kafka or 10 million messages on Kafka. So maybe it would be better to spin up, to start new instance with the consumer based on the size of messages on Kafka that are not yet processed. And speaking about auto-scaling, I think what first comes to our mind is a situation like, imagine you have an app, you're the owner of some shop, and there is Black Friday coming. So you expect there will be more traffic on your website. So if you have auto-scaling, okay, it will scale up, there will be no problems. But with auto-scaling, you can also really save money because usually we're quite defensive when we try to estimate how much resources will be needed. And for example, if most of the week or your clients, you have clients from a single geographical region, maybe at night you don't need 10 instances, maybe you need only 3. And it can automatically scale down, and on average, you may have less instances running. So yeah, you can really save time with this and save money. Okay, I'm slowly running out of time. But tracing. So tracing, so what happened, how much time it took. Also, traces hold some metadata. This is how it looks like. So this is a screenshot from Jaeger, a backend for tracing. So you can have a look how much it took to process a request. If you have multiple services, you can also have a look at that. If you have internally database call or some logic or something else, you can also see individual traces. Okay, I think I should mention during this presentation OpenTelemetry. It's connected with observability that I mentioned. It's a standard, still fresh and evolving. It's not an implementation, just a standard. It covers traces, metrics, and logs. You need to choose backend. For example, Jaeger supports OpenTelemetry. It has a collector for that. And it's application responsibility to send traces. So we not only have metrics, logs, we also have traces. We can have traces. This is the example, also with Zio and with aspects. So you have some effect, and you trace it. You create a span, and at the same time, you update some metrics. So that's as easy as that. Even I believe for Java, it can work with Scala. You can have you can create those traces automatically, so you don't even have to add the code here. There is a Java agent. Okay, so it's time for some conclusions. We saw that in order to take advantage of the features that the runtime platform gives us, we need to help. We need to step in as developers. We need to implement health checks. We need to implement graceful shutdown, maybe fast startup. We need to do something, right? We need to care about exit codes. I haven't covered everything here, but hopefully the stuff that I covered will be helpful. Yeah, I still have 1 more minute, as the timer shows. That's great. But I also know we had a talk about concurrency. So I know that I cannot compete with you being hungry. There is a lunch break. So yeah, we have priorities. Yeah, in this talk, it has much lower priority than lunch. I know it. I know it. But if you have any questions to me, you can ask them now, or you can just come to me. We can meet afterwards. Oh, by the way, yeah, there is also last slide. Thank you. This presentation is available online. You can find me on LinkedIn also. Yeah.